Hey everyone, in this video we are going to talk about Kahn's algorithm for topological sorting in JavaScript. So I tried to find this algorithm or something that works for me, but I couldn't find any code in JavaScript, so that's what I'm going to teach you today. Let's get started. So first, let's talk about what this algorithm is good for. If you have a situation where you have certain nodes in a graph and those nodes depend on each other, then this might be a good solution for you. But in order to work this algorithm, you have to have a graph that is a directed acyclic graph, which means that it shouldn't have any repeated cycles. So first of all, let's see the definition. So a topological sort of a directed acyclic graph is a linear ordering of vertices such that where if we have a directed edge from U to V, then U always comes before V in the ordering. And an example would be this. So if we just consider these two edges, the socks and shoes, and I'm going to explain this example later on, but if we just consider these two as U and V, then socks would always come before shoes and not otherwise. Now let's have a look at some directed graphs or directed acyclic graphs and some non-DAG. So this one right here is a directed acyclic graph. Why? Because you can see that each node points to another node and there is no cycling back, so it's only directed towards forward. For instance, you can see 5 goes to 0, 4 goes to 0, but there's no node coming back from 0 to 4 or 0 to 5, or even going forward there is no arrow returning back to a previous node, and this is what a directed acyclic graph is. Now if we talk about a non-DAG, it looks something like this. You can see that here we have 5 pointing to 4, 4 pointing to 3, 3 pointing to 2, and all these arrows are going forward in single direction. But this 2 is now pointing to 4, which means that it is cycling back to 4. So it is kind of stuck in a loop, so to say, from 2 to 4, 3, 2, 4, 3, 2, and that is a non-DAG, right? Now let's have a look at a really quick example that we are going to follow in this tutorial. We have this particular graph in which we have certain nodes, and all of these nodes are directed forward, which means this is a DAG. And the nodes that we have, if we look through them, what's happening is that we have to go to office, and in order to go to office we have some certain conditions that we want to do before a person can go to office. So what are the situation here? First of all, we have to wear a shirt, or we could wear socks, or we could wear pants, and I'm going to explain to you why we can choose either of them. But the situation here is that in order to wear shoes, for instance, I have to first wear socks. So I can't wear socks after I've wore shoes, right? So in order to wear shoes, we have to have socks. In order to wear shoes, I have to wear my pants first so that I can wear shoes. So all the incoming arrows means that this particular node is dependent on the nodes from where the arrows are coming. So this shoes is dependent on pants being worn. Similarly for the socks, so I cannot wear shoes until I have gone through wearing my pants and my socks both. Similarly, I cannot go to office until I have worn my shoes, also until I have worn my jacket. So these are the two dependencies for this office. Similarly, I cannot wear a jacket until I have worn my shirt. So I have to wear my shirt first and then I will wear my jacket. Otherwise it would be absurd, right? So in this particular situation, if we try to linearize somewhat this situation, it could look something like this. So you can see that in order to go to office, I have to go through this set and then this whole set. Why? Because I have to wear my jacket, and in order to wear my jacket, I have to wear my shirt. Similarly, I have to wear my shoes, and in order to wear my shoes, I have to wear my socks and my pants. So once I've done all of these, only then can I go to office, right? So I hope this makes sense. Now if we talk about the algorithm, this is how it looks. So let's go through all of this one by one. So I'm going to show you the queue that we have here. So we are going to bring the queue and the sorted queue here. And now let's talk about the algorithm itself. The first thing is to provide a degree to each of these nodes. For that, I'm going to use the diamond shape. So I'm going to put a diamond here, and then I'm going to provide this a degree of 0. Let's increase the font size. So this is the degree for this node, and then I'm gonna quickly style it a bit. So let's put a degree 0 here as well. Now that we have the first step done, the second step is to update the degrees based on the incoming arrows. This shirt doesn't have any incoming arrow, so it's 0. This jacket has one incoming arrow from shirt, so we are going to update this to 1. The office has two incoming arrows, one this one and one this one. So we are going to provide this 2. Similarly, socks doesn't have any incoming arrows, so it's 0. Shoes has two incoming arrows, so we are going to give this a degree of 2. And then pants doesn't have any incoming arrows, so we are not going to give it anything. Now that we have all these values provided, we have to move all the nodes with degree 0 to the queue. So in order to do that, what I'm going to do is I'm going to just paste all the nodes here just for reference. And now let's talk about moving these into the queue. So first of all, we have to move all the nodes which have the degree 0. So in order to do so, I'm going to move socks, shirts, and pants into the queue because shirts, socks, and pants have 0 degree, right? Now we can pick either of those. It doesn't matter because all of these have 0 degree, so we can start from any one of those. So I'm going to pick socks first. So let's move socks to the queue, and then we're going to see, hey, which node the socks points to. So you can see that the socks actually points to shoes. So in order to move forward in this algorithm, what we want to do is wherever this socks points to, we are going to go to that node and decrease the degree by 1. So since this is being pointed by socks, we are going to decrease it by 1, which makes it 1. Now, in this whole process, if ever there comes a point where a node's value is decreased and becomes 0, then we also have to add that node to the queue now. Since it has decreased to 1, we are not going to do that. Now let's pick another node from the queue. So we are going to put shirt here, and now we are going to see where shirt points to. So you can see that the shirt points to jacket. That's why we are going to go here and decrease it by 1. So now this becomes 0. Now this jacket is 0, therefore we are going to move jacket into the queue. Alright, now we have two options to pick from. We could either pick jacket or we could pick pants. So I'm going to pick pants for now. So if I move to the queue, then we have to see where does this pants point to. So you can see that the pants points to shoes, and therefore I'm going to go here and then decrease it by 1, which makes it 0. Now shoes had become 0, so now I'm going to move shoes to the queue. Now I could pick either shoes or jacket, so I'm going to pick jacket first. So now I have moved it here, and now I can see where jacket points to. So you can see that jacket points to office. Therefore, I'm going to go here and update it to 1 because I'm decreasing it by 1. Now this is still 1, so I can't do anything, and the only thing in queue is now shoes. So I'm going to move shoes to the queue, and now I'm going to see, hey, where does shoes point to? So you can see that the shoes point to office. I'm going to go here, and then I'm going to update it to 0. And finally, we have the whole graphs sorted based on a particular sort value. So if I go down here, this is how the sort looks like. We have socks, shirts, pants, jacket, shoes, office. Socks, shirts, pants, jacket, shoes, and then finally we have office. We actually left office for office, so I'm going to move it here just to make you understand what's happening. So this is sort of the queue that we have finally found out, and just to make sure that you understand that this is one of the potential ways of getting this output, or just one output of many. And why am I saying that? Because I could have started from shirt, or I could have started from socks, or I could have started from pants. It doesn't matter, and the result then would be different, of course. But in this algorithm, or the problem this algorithm solves, is not to give you a single output, but the problem is solved is that every dependent node comes after the dependency. So as I said, if there's a node pointing from U to V, then U would always come before V. And in this situation, we can say that one cannot go to office until all of these steps are done. Or I can say that I cannot go to office and then wear my shoes. So I cannot actually say that, hey, first I'm going to wear my shoes and then I'm going to wear my socks. That doesn't happen. Now it doesn't matter if I'm wearing this jacket after or before the shoe, because the arrow doesn't point to that, right? So I could wear my jacket and then wear my shoes, but I have to wear my socks before I wear my shoes and my pants before I wear my shoes, because this shoes has incoming arrows from socks and pants. Now let's try to actually build this into JavaScript, and we are going to see how that works in a particular example that we are talking about. So we have a really simple application that just has some HTML and a JavaScript that we have created, and this is empty right now. There's no output of the application as well. Now let's start by just adding these graphs as an array into the code. So let's do it. So I'm gonna go here and create the nodes. So let me tell you how this looks. So we have an elements array, and each element here is a node. Each node has a degree. By default, if there is a node with no incoming arrows, then the degree is 0. But if there is a node with incoming arrows, we do point out to the nodes from where the arrows are coming. And also we have the degree equal to the dependencies. So for instance, this socks has a degree 0, which is because the socks doesn't have any arrows incoming. But let's talk about the example of office. This office has 2 arrows coming, one from shoes and one from jacket. So if I go and look into the code, you can see that the office has 2 incoming arrows from shoes and jacket, and the degree is 2. So we have the data according to how we would visualize this graph that we just talked about. Now all we need to do is to implement the sorting algorithm. So we are going to start with just defining a function. So we are going to say sort by Kahn's algorithm, and then we are going to accept an array. So we could say elements array, and then we are going to do some magic here. Finally, we have to just return a sorted array. So we could just create an array for that, and we can call it sorted, or let's say a sorted queue, so it matches with what we have discussed in the diagrams. And then we have a queue, so we will just say queue. So we'll just say queue, and then let's initialize this as an empty array. Now we already know that the queue always starts with all the elements which have degree 0. So we can, instead of doing this, we could say elements array dot filter, and then we would have an element, and then we can say element dot degree equals to 0. So we will be initializing the queue with all the elements that have the degree 0, and then we can get the remaining elements and just add it to, let's say, something called a stack blooper. And then we can just add the remaining items into, let's say, a variable called array. So we can say array equals to, and then we are going to say elements array dot filter, and then element equals to, and then we are going to say element dot degree not equals to 0. So all the elements without the degree 0 would be there. So let's just save this and print out both of those values. So I'm going to do a console.log queue and a console.log array. Let's save this and just call this method by using the elements array. So I'm going to just do a console, or just say cons result maybe, and then console.log result. So now that we have done this, let's blooper. So now that we have done this, let's see the result. And before going forward, I need to change this to elements because that is the name of the array. So let's save this and try this out. So refreshing basically shows us the values. So we have this, which is the queue, and then this is the elements array. So you can see that the socks, shirts, and pants, these are the things that we have in the queue. And then we have shoes, office, and jacket, which are just in the array. Looking better at the diagram, you can see that initially we had shirt, socks, and pants, which have no incoming arrow at all, right? And then we are going to write a while loop which will run through the queue and then perform the rest of the steps for the algorithm. So we are going to start with saying, hey, if we have items in the queue, then we have to run this algorithm no matter what. And from the end of the function, we need to return the sorted queue, as we know. And then let's talk about what happens inside. First of all, we are going to take out the first element from the queue, and then we are going to evaluate it. So we are going to say current node equals queue.shift. So it is going to take out an item from the queue and assign it to current node. Then what we need to do is we need to basically check if this node exists. If not, then we are going to just say that queue.length equals to 0. So this while loop can exist. So we can say if not current node, then what we need to do is we are going to say queue.length equals to 0. And that is it. Otherwise, we are going to perform the whole algorithm. So we are going to say else, and now we're talking. So we are going to say, hey, the first thing that we need to do after dequeuing an item from the queue, we need to put it to the sorted queue. So we are going to say sorted queue dot push, and here we are going to pass the current node. Once we have pushed this, now we are going to see which of the elements in this array is dependent on this current node. And we do that by just looping over it. So I'm going to say let I equals to 0, len equals to array.length, and then I'm going to say I less than len, and then plus plus I. And then what we are going to do is we are going to say find out if there is a dependency on this current node for a particular element. So we are going to say const, and then we are going to say element equals, and then we are going to say array I. And now let's talk about this element. So we are going to say const has dependency on current node equals, and then we are going to say element dot depends on, which is the array that we talked about. So we are going to look into this array for each element, and then we are going to say element dot depends on dot find. Then we have the dependency, passing it here, and then we are going to return if the dependency equals the current node that we have, so the name of the current node. So once we do this, we should be able to see if there is a dependency or not. And I'm just going to put these double exclamation here, so we have a boolean value finally. So I'm gonna quickly check here and say if has dependency on current node equals true. So if it's true, or I could just say this. So if that's the case, then we need to decrease the degree of this element in the loop by 1. So if we have found the dependency, then in the end we'll do a break, but we also want to do element dot, or actually instead of element, I'm going to use array I. Although I could use element, but I could say array I dot degree minus minus. And then I'm going to check if the degree has decreased to 0, in which case we have to push this element into the queue. So I'm going to say if array I dot degree, if it equals 0. If that's the case, then we need to push this into the queue. So we are going to say queue dot push, and then we can simply say array I. And now we are done. So we are going to push this into the array and we are good. And we are also breaking from here. And actually, now that I think about it, we don't need this break because one element can point to different places or to different arrows. So now that we have this one, let's just save this. If I refresh now, I get some results, but I'm going to go here and in the debug mode, we are going to see how this works. So if I refresh, you can see that we have all the graph nodes here. Then we basically come into the function because we are calling it from here. I'm going to put a breakpoint here as well, just to see the final output. So first we initiate a sorted queue, which is an empty array in the beginning. Then we create the queue with all the elements with degree 0. So if I move forward, you can see that we have all the elements with degree 0, socks, shirts, and pants. Then we have all the elements with non-degree 0 moved to the array. So this array contains all the elements which don't have a degree 0. And then we start the while loop. So the queue.length is 3. The first step in the queue is to take out the current node. So you can see that right now queue has socks, shirts, and pants. And the shift method takes out the first element from this queue. So if I move forward, you can see that the current node now has socks, which was the first element. And now the queue has 2 elements only, which is shirts and pants, because we have shifted it out. Now, since this current node exists, it's not going to go into the if, but it will go into the else. And now the first thing that we do is move this socks to the sorted queue. Now, if I go back to the diagram, you will notice that the first element that we pushed into the sorted queue was socks. And then we looked at where the arrow from socks goes to. So the arrow from socks goes to shoes, and that's what we are going to check, and will reduce the degree of shoes. So here, if I go forward, you will see that we first take out the current element array. So we are first looking into shoes, and shoes has a dependency on sock. So if I move forward and go through all this chunk here, we finally got a dependency on the current node, which means that this shoes depends on socks, which is okay. So we go forward and then we take out the degree of shoes and decrease it by 1. So you can see that the shoes has a degree of 2 right now. But if you go forward, now the shoes has a degree of 1 because we decreased it. Since it doesn't have a degree of 0, we will not push it to the queue. And then we move forward and check the rest of the elements just to make sure that we don't have any particular arrow going out to any other thing as well. Now we are done. We only see the queue has two things, shirt and pant. So we take out the shirt first, which was the first one, and then we do the same thing. We push it to the sorted queue, socks and then shirt. If I go to the diagram, you can see that we had socks and then shirt, and now we should be able to see that jacket has a dependency on shirt, so we decrease the value of jacket. So we go forward and then we find the dependency. So we find dependency as a false first, then we move forward, and then here we got false and move forward, and here we got true. Now which element has the dependency? Jackets. So the jacket has shirt as a dependency. So we go forward and then from the array we basically remove the jacket's degree or decrease it by 1. Right now the jacket has degree 1, we move forward, and now the jacket has degree 0. Since the degree is 0 now, we move forward and we push it into the queue. So you can see that we are moving or we are pushing jacket to the queue. And now queue has both pants and jackets. Now you know that since we are using the shift method, pants is going to be evaluated before jacket, and that is fine. There's no problem with that. So similarly, the process goes forward. We keep the queue going, and then I'm just going to be removing this from here just to show you when we push to the array. So we are going to push the particular element into the queue. So queue had jacket only, and then once we move forward, queue then had jacket and shoes. This goes forward, 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 and finally we return the sorted queue. So if I look at the sorted queue, you see that we have socks, shirts, pants, jacket, shoes, office. All of the elements in the right order as we discussed in the image. So if we see the image, socks, shirts, pants, jacket, shoes, and office. So I hope that I was able to explain the Kahn's algorithm in a good manner, and now you have a good understanding of how it works. This algorithm is actually implementable in real life. That is why it was created, and I have personally used it in one of my projects as well. So I hope you liked the video. If you did, press that thumbs up button. Make sure to write in the comments how you feel about this video. Subscribe to the channel if you have not, and I'm going to see you in the next video.